Welcome Algebra 1. This is a video on change of base and logarithmic equations. Let's begin. So just a reminder, these are how to write a logarithm and then in exponential form. Some notes about logarithmic notation. Log base 10 of x is the same thing as saying log of x, just with nothing there. When you have nothing there, the default is to say it's base 10. So if you see on a calculator, see a button that says log, this is actually log base 10. So it's taking something to the 10th base when you hit that button. Another thing, log base e of x is equivalent to ln of x, or the natural log of x. So you might see if you have like a graphing calculator, TI-89, there'll be an ln button. The ln button, or some scientific calculators, means you're taking it to the base e. And we use that in a lot of applications. So just a note. Change of base formula here. So if we have some log base b of m, we can rewrite this as changing both of this in a different base. So log base b of m equals log base c of m over log base c of b. So basically, you use this when we have some base that we can't really use that easily, especially like if we're trying to evaluate it and we have a calculator but it doesn't work. So let's say if it was some log base 3 and there's no log base 3 button on a calculator. You can convert them to some log you have, maybe like a log base 10 button because you have that, or a natural log button, log base e. So that's what we really use it for. So this works for any positive numbers, m, b, c, where b can't equal 1 and c can't equal 1, because then you couldn't have log base 1s. This is useful, again, calculators and evaluating common bases. So let's take two examples. I want to use the change of base formula to evaluate its expression. So when you're doing this stuff, you'll need a calculator. I don't have a calculator that plugs in log base 2 of 3. That's just not a common function in a calculator. But what I have, I'm looking at my TI-89. You have a log button here, my graphing calculator. So you can convert this. Let's convert it to log base 10 form. So I'll write this as log base 10 of 3 over log base 10 of 2, which is the same thing as saying log of 3 over log of 2. And you type those into a calculator. So if I type into mine, I'm sorry you can't see this, but if you have a calculator at home, you should type along with me. And you're going to get approximately 1.58. We'll just leave it 2 decimal places, hundredths. So that's approximately rounded to the nearest hundredths place. If you don't have, your calculator only has ln, natural log, like a TI-89, you could have done natural log of 3 over natural log of 2, and that'll still give you the same thing, 1.58. It's kind of cool. Okay, so let's try this one. I can convert this to the log of 42, because log base 10, over log of 5. And if you plug that in the calculator, you're going to get log of 42 divided by log of 5, and you should get about 2.32. So that should be your answers. You will need a calculator to make this work. All right, so change to the same base to solve exponents. We did this a little bit last week. I just kind of want to review this. To solve for x in this case, what you could do is you could change these to the same base. 27, 81. 27 is the same thing as 3 cubed to the 3x power, and 81 is 3 to the 4th power. Multiplying these exponents there, the 3 to the 9x power equals 3 to the 4th. Since they're the same base, I can just create an equation for the exponents. So 9x equals 4, and divide both sides by 9. My x equals 4/9. All right. But sometimes in a case like this, we want to solve for x, but you can't just, that's not really easy to do. There's not the same base right here. So what we can do is we can use our logs. We can actually log both sides of the equations. So in this case, we're going to take the log of both sides and go log of 3 of x equals log of 2. This is like log base 10. And using our properties of exponents, we can take this x and make it a coefficient. So x times log of 3 equals log of 2. Or we can divide both sides by log of 3 because it's just some number. So we get x canceling, so we get x equals log of 2 over log of 3. And if we plug that into a calculator, log base 2 divided by log base 3, and you would get approximately 0.63. All right, let's try a different one. So same thing, we want to evaluate as well. This is not the same base here. So I can log both sides. So what you're going to get, and I can take that 3x to the outside, so 3x times log of 15 equals log of 285. And if you want to isolate the x, divide both sides by 3 log of 15. what you get, x equals log of 285 over 3 times log of 15. And yep, you have to plug that into a calculator as well. So 285 divided by, make sure it's order of operations here, 3 times log of 15 on the bottom. And what you'll get is approximately 70 hundredths right there. That's rounded to the nearest hundredth. All right, next one. So some of the neat properties of this, any b to the log base b of x power, it just comes out to x. So like if you take something to a b power, when you a log base b of x, and to the b power both sides, it kind of cancels it out. It's kind of like when you're taking the square root of a square. So if you take like the square root of an x squared, and that comes out to x, it's kind of the same, similar properties here. So if I wanted to find log of x equals 2 and solve for x, you could take both things. This is like log base 10. I could take both sides to the 10 power, and this will just end up being x equals 10 squared, so x equals 100. But you know what? You could have converted this to exponential form anyways and found out 10 squared equals x, so not really that necessary, but just kind of neat. Let's try some examples. All right, using the change of base formula here, so log of 39 over log of 4. And if you plug that into a calculator, log of 4, you will get 2.64. Yep. Next one. All right, I'm going to log both sides again. And then when you do that, I'm going to take that 2x and put it as a coefficient. So 2x times log of 5 equals log of 130. And I'll divide by 2 log of 5 on both sides. Oh gosh. Okay, and so what happens, you're left with x equals log of 130 over 2 log of 5. And if you plug that into a calculator, and if you wanted to simplify the 30 over 5, you could. We don't need to do that right now. So I'm going to do log of 130 divided by 2 log of 5 into my calculator, and it looks like I get approximately 1.51. All right, next, and that's it. Boom.